So we are now doing question number 19. It asks, the two disks are now shifted so that the axis of rotation goes through a point on the edge of the disks. The rotational inertia of the two-disk system is now either 2mr squared, 3mr squared, 4mr squared, 5mr squared, or 10mr squared. So in order to solve this, we're going to want to use the parallel axes theorem, which tells us that the moment of inertia of an object is equal to the moment of inertia of that object around its center axis plus the mass of that object times the distance squared the new axis of rotation is away from the center axis of rotation. So we have our moment of inertia final is equal to moment of inertia central plus mass times distance squared. So IF equals the moment of inertia for the center is mr squared over 2 because the mass of the system is now twice as much as it so the initial moment of inertia was for the singular disk because it had a massive m, so it was mr squared over 2. But now we have a disk that is twice the mass because the second disk fell on top of it. So that's going to be 2m, and then the distance away from the central axis is just going to be r, because it's been moved from the center to the edge of the circle, which is the radius. So distance r, so that gives us r squared, like that. So, or wait, no. The initial moment of inertia is also 2m r squared over 2, because we're to use the parallel axis theorem, you need to be using the same mass object. You need to be using the same object. So the moment of inertia is initially 2m, because it's twice the mass times r squared divided by 2, plus 2m, which is the mass, times r squared, which is the distance squared for the parallel axis theorem. So then what we do is we can cross out those 2's. So the moment of inertia final is equal to mr squared plus 2mr squared, and that gives us 3mr squared for our final moment of inertia, and that is B, 3mr squared. Yeah, the the moment of inertia, the parallel axis theorem, it doesn't work if you... I made a mistake before because I I had the first m as a singular m